In this lecture, it's time to load the input actions file into the scene. We have an object for storing this file's data called Game Manager. Let's enter prefab edit mode for this prefab. Next, on the inspector, add a component called Player Input. This component becomes available after installing the Input System package. Its job is to load an input action file. Let's quickly review the settings. The first setting is the file. Let's click on the button to open a window for selecting an input action file. There should only be one file. Select it from the list. Great! It's as simple as that. We've successfully loaded this file. Let's continue configuring the options. The next option configures the default map. The component automatically finds a complete list of action maps from our file, which are called Gameplay and UI. Let's select the Gameplay action map. The next option is called UI Input Module. This option is for connecting the UI of our game to the file. However, UI is not a topic we'll cover in this section. It'll be covered later. For now, let's leave it empty. Up next, we have an option called Camera. If our game has multiple cameras, we may want to control a single camera with our actions. For our game, the camera won't be controllable through an action. We can safely leave this option empty. Moving forward, the last option configures the behavior of this component. This component is capable of informing our objects that an action has occurred. There are different ways of sending this information. Most of these options won't be covered. Our original goal was to use events. Select the Unity Events option. By selecting this option, the component creates events from our actions. Below the field, a new drop-down becomes available called Events. Taking a peek inside, a complete list of events is presented. We have events for handling device connectivity issues. In addition, events from our action maps are available. By default, the component will use the name of the action as the name of the event. If we have an action called Move, the event will be called Move. If we have an action called Attack, the event will be called Attack. So on and so forth. Let's exit prefab edit mode. Before adding event handlers to our events, we should do so from the scene. If we were to add event handlers from prefab edit mode, the game manager would expect these methods to exist in all scenes. Initially, that may seem like a good idea. After all, the player should be accessible for every scene in our game. But what if we create a cinematic? Not all scenes have to contain playable levels. You can create scenes to create cinematics in your game. Players should not be able to interact with an object while a cinematic is playing. Rather than adding handlers to the original copy, they should be added for each scene. The process is more manual, but safer than expecting the player to be movable in every scene. Select the Game Manager from the hierarchy. Open the complete list of events for the Gameplay action map. For this lecture, let's focus on the Move event. Click on the plus button. Here's the cool thing about events. A limitless number of event handlers can be attached to an event. We're not limited to a single event handler. That's great. This feature will help update multiple game objects from a single event. After adding an event handler, we can configure the settings for this handler. For example, we can run the method while the game is playing, which is called runtime. Alternatively, we can run the method while the game is playing or while we're editing the game. Lastly, we can disable an event handler. We may want to use this setting for debugging a specific handler. If we have multiple event handlers on a specific event, they can conflict with each other. We can pinpoint the problem by testing one event handler at a time. In most cases, you should always select runtime. From my experience, I've had issues with running methods while editing a script. It's safer to use runtime mode. Next, we can select a game object. press the button to open a list of game objects. In the past, students have selected the wrong game object. There are two lists. Make sure the Scene tab is selected. Game objects from the Assets tab are not active game objects. If we were to add a game object from this tab, nothing would happen in our game. So, be sure to select Objects from the Scene tab. From this list, search for the Player game object. Great! The last step is to call the method from this game object. In the drop-down, we are presented with a complete list of properties and methods available from the game object. If we have components, their info is exposed to us. This is why our event handler must be public. If our event handler was private, they might not appear in this list. Select the Handle Move from the Movement component. We're finished. Time to test our work. Hopefully, everything works. In the Unity editor, open the console window. If there are messages written in the console, clear them. Next, play the game by pressing the play button. If we were to press the WASD keys, the message from our event handler would get printed in the console. After almost an hour of work, we can capture the user's input. Before ending this lecture, there's one thing I want to mention. In the console window, reading duplicate messages can be annoying. It can be easier to read the console by pressing the Collapse button. This button will merge duplicate messages into a single log. The number of times a message has been logged is counted to the right. If we have a unique message, that will have a separate log. Throughout this course, I will toggle this feature on and off. Now that we've verified the player is receiving the input from a controller, we can start moving them around the map. In the next lecture, let's begin this process.